to represent piecewise functions. And what that means is we're actually taking pieces of lines to put them together to make a new graph. So piecewise functions are actually used a lot in our everyday life. You may not actually draw out the graph to represent that, but car manufacturers use it. If you know, like, if you live in a city, if your gas mileage is good as if you live in the country. You say no, why? You're right. Yeah, there's more stop and go, right? So that's actually two separate functions. Now, raise your hand if maybe you live in the country, but you plan to work maybe in a city. So you're going to have both of those, right? Depending on how far into the city you work or how far into the country you live, you're going to have two different functions you have to look at. Salespeople, this is a big one for them. A lot of salespeople make commission. Have you guys heard of commission before? Okay, that means like you sell $1,000 worth of stuff, we're going to give you 10% of whatever that is. But if you sell $2,000, we'll actually up that to 15%. That gets them to sell more items, right? Well, that's two separate functions with two different constraint values. So we're going to start with just some basics. And this is what a piecewise function looks like. Meaning I've got two separate pieces here, two different functions with two different constraints. Go ahead and copy that down beside graph 1. So in a piecewise function, you actually have two different things going on. This first item are called your constraints. Your constraints help you to know what your domain is. So another word for constraint may be domain. So notice on the top constraint, I have to be less than or equal to 3, but on the bottom constraint, I have to be greater than 3. Do they overlap at all? What do you guys think? Do they overlap? No, they don't. One has the equal sign and then the other one does not. Your constraints will never overlap. Your constraints will never overlap. Now these are called your functions. Now only one function at a time can be used, and it all depends on your constraint value. So we're going to evaluate for x equals 0, or another way to say that is we're going to find f of 0. In your book, they like to write it in the function notation. So I want you to be able to see both and understand in both items there, I'm looking for x equals 0. So if I'm evaluating for f of 0, which one does the 0 fall into with my constraints first? Top or bottom? Top, right? So that means I'm only going to plug that 0 into the top function. I don't care about the bottom one. So 3 times 0 plus 2 is 2. So f of 0 equals 2. So I look at that constraint value first and then plug it into the correct function. Does that make sense? Okay, so what I want you to do right now is to look at the second one here. I've got x equals 3. I want you to think in your head, don't say it out loud, which one would you plug it into, top or bottom, in your own head? Everybody have an answer? Leaders, I'd like you to say it to your group. You're going to be talking a lot in the group, but I want you to be able to, discuss. If you want to leave your book there, that's fine, whichever. I just don't want you to have to, talk to yourself. Okay, so leaders, tell your group top or bottom. You guys all agree? Do you have any disagreements, maybe? Well, let's check. Who's your leader in this group? Angela. Angela, which one did you say? The top one, because it has the equal sign. That's right. All right, everyone, go ahead and plug in your answer. Or plug in your number to that equation and find an answer for me. Evaluate. F of 3 equals you to tell your answers to the entire group. Everybody good? Here's Angela. Pick a group. Which one's that one? This one? Who's your go first? Brianna, what'd you get? 11 is right. 3 times 3 is 9, plus 2 is 11. Does that make sense? Okay, evaluate the last one, f of 6. Or x equals 6. F of 6. Timekeepers, I want you to tell the answer to everybody. Everybody good? Brianna, pick a group. Timekeeper? 5 is right. F of 6 equals 5. Okay. So what I want you to do right now is discuss with your group, how did you do this in English? Like if you were having to put this on a chapter test, explain to somebody who has no clue what a piecewise function is, how to evaluate one. I want you to talk in your group and then write yourself a note to your future self. Nathan. Which one did you plug it into? So, but notice this says x has to be less than or equal to 6. So I want to choose the bottom one because 6 is greater than 3. That make sense? Okay, so take a minute. I want you to discuss in your group. Okay, because a chapter test question may actually be this time. Explain to somebody who's never seen this how to evaluate it. And I want you to write a note to your future self. How did I do that? So you can look back at it right before the chapter test and get an A on that question. So, after you wrote that down, you've all discussed it, you seem to have a better understanding. I saw several of you writing extra things on yours. That makes me very happy. Very happy. So here's our next one. You can write this down beside the next graph. Yes, it's a lot longer, but in all honesty, it's a lot easier. So take a minute, write that down. So what I just asked you to do is to talk to your group. Don't write anything down with what I told you to do. And to figure out what you would do to find f of -4. Now, by a show of hands, if you're not afraid to show them, raise your hand if you're confused on what to do on this one. Okay. Now, watch. What's different between this one and the last one that actually makes it weird or different? Raise your hand if you can tell me what's different between this one. Nathan. Okay. So these ones have 2 signs in them instead of just one. That's a good start. All right. Anything different otherwise? One more time. So there's 4 of them altogether, right? So the difference here is now there's 4. There's not just 2 that you have to figure out, right? Okay, that's another difference. Anything else that you notice is different? Sean? There's no x now, right? And what you had said before was you plug it in to the function. Okay, so I understand now why you guys are so confused. It's because it's completely different, isn't it? Now, I'm going to show you how to do this one, and you're going to be like, oh, that is a lot easier than I was originally thinking. First off, what's another name for f of x? So technically, this is y equals 1, y equals 2, y equals 3, and y equals 4, right? So, okay, that's going to help me to graph here in a little bit whenever I get to the graphing part. But we're going to find f of -4. Well, which constraint does f of -4 fall in? The top, the middle, the top one, right? Because -4 is equal to -4. Do you guys agree? Well, what y value is there? So f of -4 is 1. There's no x value to plug it into. You just get out the y. Does that make sense? Now see if you can evaluate the bottom two. You can talk to your group, discuss with your group, go and write down the answers you think for the bottom two. All right, so I asked you to do two other problems, f of -2 and f of 0. Um, Dalton, what did you get for f of -2? Okay, so let's go through it one more time then, Dalton. Which one would -2 fall into? Which of these two strings? The third one. And what does y equal in the third one? There you go. So that one would just be the number 3. Okay? And raise your hand if you got that one. All right, so we're doing pretty well there. But this f of 0, that's always an interesting one. Let's go with Nate. What did you get for f of 0? You got the fourth one, so what number did you write? Okay, so Nate wrote 4. Raise your hand if that's what you wrote down also. Okay, put your hands down. Raise your hand if you didn't write that down. You disagreed with them. Okay, so this one's actually, Nate, a trick question. Notice we're in class, we're doing it together. I'm not going to try to trick you on a chapter test or something like that. But right here, I am trying to be a little tricky. Does this actually say equal to 0? Do any of them have 0 that fits in? No, so we're actually going to say undefined. Undefined, you don't have to use those words. You could use not possible. Okay? Either of those. But that one's a tricky question there. But notice, Nate, you weren't the only one that thought that, were you? There's half the class thought that, and then the other half were like, that seems weird. So make sure you go with looking at those signs to double check yourself. Well, you already wrote that down, so let's go ahead and graph it. So our next step is we're going to graph that. Now, I believe it was Sean that said the weird thing in here was that there's no x value, right? Is that what you had said? Okay, there's no x's. When you see no x's in your function, we actually call this a step function. We're going to graph it, it's going to look like steps. So when we graph it, it will actually look like steps are going on. Step functions are my favorite to graph. They're actually very simple once you understand them. Right now, they're very puzzling, right? Because it's something you've never seen before, never done. Well, before we actually graph, let's talk about open and closed circles. At this equal to, do you think that'd be an open or a closed circle? Good. How about this one? Okay, so we've got this. Closed, open, closed, open, closed, open. You guys all understand that? Okay. Something we've already done, we've already talked about, right? Well, these are my domain numbers, my x numbers. So I've got -4, and what's my y value that corresponds to it? 1. So I'm going to go to -4 on my x value, and up to 1, and you told me to put a closed dot right there. So I'm going to put a nice closed dot at -4, 1. Does that make sense so far? Okay. Well, what x value does this end at? -3, right? And it's still what y value? 1. So I'm going to go to -3 up to 1, but I'm going to put in open dot this time. And then I'm going to just connect them. Connect those two dots, and that's my first step. Does that make sense? How about I do one more with you before you write a note to your future self? That way we actually understand it, make sure we've got this. So I'm going to do number 2 now. I'm going to start at -3 on the x-axis and go up to 2. Put what kind of a dot? Closed. I'm going to go to -2 on my x-axis and up to 2 and put in open dot and connect those. Does that make sense? Okay. So I want you to write a note right now. How do you graph a step function? How do you graph a step function? How do I know where I start these points and then I the very last statement should be connect the two dots, right? So how do I know what points to put on? So I'm going to go ahead and finish graphing this as you guys are finishing up. I'm going to go to -2 on my x value, up to 3 on my y. -2, up to 3, closed dot, right? Now I'm going to go to -1 and up to 3, open dot, and connect that. And then my last one will be right here. Okay? Does that make sense? Okay. Now, I heard some of you talking, but I do want you to go around the group again. Start with your gopher this time, but go around your group. I want everybody to read, how did you graph a step function? Go ahead. Okay, first off, before we move on from this, and since you guys have already talked about it, let's review one more time. How did you know it was a step function? Raise your hand to tell me. Mason. Okay, well, it doesn't have to have multiple. I may just give you 2, and it would still be a step function. That's the key thing. There's no x's here, okay? So it can range from 2 to like 5,000 if I choose 5,000. I'm not that mean, by the way. You won't get 5,000, Dalton. It's okay. Okay, but it can range from 2 numbers to a lot of numbers. Does that make sense? But we know it's a step function because there's no x. So let's do one more that's not a step function. Go ahead and copy this beside your next available graph. So this one you can automatically tell it's not a step function, right? Because you actually see the x's right here, and you can tell it's going to have a slope. Like the first one's going to have a slope of 3, and the bottom one's going to have a slope of -2, right? So you know it's got to have a slope with it. So this is actually where you're going to have 2 different pieces going in different ways on the graph. So we're going to give you some different steps to help you out. So this time, instead of you writing a note to your future self, I'm actually writing notes right now to your future self. So step 1, plug in the constraint numbers to the function. So step 1, plug in the constraint numbers to the function. Even if technically that constraint number shouldn't be plugged in there. Meaning, like, I'm going to plug 4 into the top function, and I know technically 4 should not be plugged into the bottom one because it doesn't have the equal sign, right? But I'm still going to plug it into the bottom function. But where I put the dot on the graph, it's actually going to be an open dot. Does that make sense? Okay. So let's go ahead and plug those in. 3 times 4 minus 7, and -2 times 4 plus 6. That's 5. -8 plus 6 is -2. Does that make sense what I did so far? So for this top one, I got the point 4, comma 5, and for the bottom one, I got 4, comma -2. Anybody lost or puzzled on how I got those numbers? Sean? The 4 was the number that I used from the constraint to plug in. Good question. Good question. Okay, step 2. Graph the point. And I'm actually going to put in parentheses right after those words, open, close. That way I remember I need open and closed circles, right? I can't just put them both as closed dots on there. They're not both closed. Is the first one open or closed? Closed. I'm going to go to 4, comma 5 and put a nice closed dot here. And then how about the second one, 4, comma -2, open or closed? Open, right? So now I have 2 points on there. Okay, but if I drew a line through, technically the line would only be hitting the first one, right? Because that second one's an open one, so it doesn't actually count. Any questions so far on step 1 and step 2? Okay. Step 3. Step 3 is this thing I'm trying new this year. So if you had me last year, I know these got a bit confusing. I'm trying something new. You're going to put arrows on. To help you grasp. Put arrows to help grasp. Now, for these ones, it's very, very important, hopefully, that you have a pencil. So if you're using pen, you may want to borrow somebody's pencil when you're putting these little arrows on, okay, in just a second, once you see what I mean with that. But try to make sure you bring a pencil for the next few days, because we're actually going to work on this tomorrow, and we're going to work on it Thursday, because it's a hard topic, it's a new topic, right? Okay, so let's look at this top one. That's the top graph here, right? Top point matches with this one. And this says X is, what's that sign? Less than, right? Is less than on this side, or is less than on this side? On the left side, right? So I'm going to put a little arrow on there. Then I'm going to erase here in a minute. That's why I'm using pencil. So I'm just putting a little arrow on to help me to know that when I graph this line, it's got to be on that side. Actually, when I graph this ray, raise your hand if you're in geometry. All right, raise your hand if you can tell me the definition of a ray. It doesn't have to be the perfect geometry version of it. What is a ray? Good. So I'm going to be starting at this point, and I'm going to go on forever in this direction some way, right? Some way. I just don't know what that way is yet. So this one, let's look at the bottom one, which will go with this point here. X is greater than, so I know I've got to be on this side. Again, I'm going to use pencil so I can erase those two little arrows. Those arrows are just helping me here in a second. Okay. So, now we get to graph. This top point matches with this top equation, right? What's the slope of this top equation? 3. So I would technically go up 3 over 1. Uh-oh. Did I make a mistake there? Am I on the side that the arrow wants me to be on? No, so what do I actually need to do then? Go down 3 and left 1. I'm going to do that a couple times. Down 3, left 1. Down 3, left 1. Does that make sense? See that point that I accidentally put on? Guess what? I have an eraser. It's gone now. That makes sense. So if you accidentally put a point on, you can always erase it. And now I'm going to connect my closed dot to those other points right there. And notice I made a ray. It started here and it went on forever down this way, right? Does that make sense so far? Do I need this arrow anymore? No, at this time I'm going to erase that arrow. I used it for what it was necessary for, to help me to know to be on that side. Now let's go ahead and do the other equation. What's the slope of it? -2. So if I go down 2 and over 1, am I on this side that the arrow wants me to be on? Yeah. I'm going to do that again. Down 2 over 1. And I get to make another ray. I'm going to start here at this open dot and connect it the whole way down with an arrow. Guess what I get to do with that arrow? The other arrow. Erase it. Does that make sense? Sort of? I'll take sort of. Okay? Alright. So I'm going to give you the essential work. Pull out a clean sheet of graph paper.